Hello aviators, welcome to Aviation Education.
So today we are going to start with the chapter 4 of the air navigation, which is convergency. So convergency by definition means the inclination between any two meridians at a given latitude. So let's understand what is convergency. So if we imagine this as a earth and the vertical lines are the longitude, which are also known as the meridians, right? And the horizontal lines are the latitudes. So for an example, we take two longitude, which is this longitude and this longitude, and one latitude, which is this one. So the angle between this longitude and the latitude, which is this angle shown in the yellow, is called as the convergency. Convergency between two meridian at that latitude. Now to find this convergency, we have one formula. So the formula goes as d long, which is distance between two longitudes, into sine mean of the latitude. Mean is the average of two latitudes, and if there is only one latitude mentioned, then it will be sine latitude. So this is going to be our first formula of the chapter. Convergency is equals to d long sine mean latitude. After that, if we see that in the formula we have the sine function, right? So the sine function is minimum at 0 degree and it increases to 90 degree. So here also the minimum convergency is going to be at the equator, which is the 0 degree latitude, and the maximum convergency is going to be at the poles, both of the poles, because that is the 90 degree. Now, the next topic is going to be conversion angle. So, by definition, conversion angle is angle between great circle and rhumb line. So whenever this convergency of the earth is projected on a map, it becomes the conversion angle. And the conversion angle's formula is conversion angle is equals to convergency by 2. So this is the second formula of our chapter. Now let's take an example. So let's say this is our two latitudes and this is our longitude. So the latitudes are 20 degrees west in 20 degree east, and the longitude is going to be 30 degrees north. So as you know, all the parallel of latitudes are rhumb line. So if a plane is going from A to B for a constant direction, it is going to fly at the parallel of latitude 30 degree north, which is a rhumb line. And if the plane wants to fly the shortest distance between A to B, it is going to fly a great circle. And great circle is a curve convex to the pole, right? So this is going to be a great circle and this is going to be a rhumb line. And the angle between the great circle and the rhumb line is convergence angle, which is the yellow angle here and here. Okay, so this is a rhumb line, this is a great circle, and this angle here is a conversion angle. So let's find out the conversion angle, great circle and rhumb line. So first of all, we need to find the conversion angle. For that, we will use the first formula first. So convergency is equals to d long into sine. As I said, there is only one latitude, so sine latitude, right? So the d long is the distance between two longitudes here are 40, right? So 40 into sine of 30. Sine of 30 is 1 by 2. So 40 into sine 30 is 20. So convergency is 20. So convergence angle is 10, right? So here the convergence angle is 10. Now if we want to find out the rhumb line, so the rhumb line at A is it is a parallel of latitude 30° north and it is going from east to west, so it is going in west direction. So west direction is always 270, right? So this is rhumb line and A is 270 and the opposite rhumb line, so rhumb line at B is going to be 090 because 270 minus 180. Okay, so now to find out the great circle from at A and the great circle at B, we are going to need the conversion angle, right? So the conversion angle is 10 and this angle, so basically his angle is 270 and plus this 10 degrees. So the great circle at A is going to be 270 plus 10° conversion angle. So that is going to be 280 degrees. Now let's see the great circle at B. This. So this direction is 090. So this is 090 and this is 10 degrees, right? So 090 minus 10 is going to be the great circle at B. So the great circle at B is 090 minus 10 degrees is 080 degrees. So we found all the rhumb lines and great circle. So rhumb line at A, rhumb line at B, the great circle at A and the great circle at B, and also the conversion angle. So with keeping this example in mind, we are going to now see the scenarios in the different scenarios. If aircraft is flying in the north hemisphere and flying east, what happens to the great circle? And flying in the north hemisphere and flying west, what happens to the great circle? So let's begin. So as we know that we are flying east, let's take the example of north hemisphere flying east. We know that this rhumb line angle is 090. This is 10 degrees and this was 080. So we are going to compare this great circle at initial departure and this great circle at arrival. So here we know that this angle is 90 degrees, but we need to know the angle here, right? At the arrival. So this is going to be same as the conversion angle, which is 10 degrees. So this angle is 90 plus 10, which is 100. So if the aircraft is flying in the north hemisphere in eastern direction, the great circle increases. So the great circle at departure is less than the great circle at arrival. Let's see the example of flying west. So if we are flying in the western direction, this is our initial Rhumb line 270, right? And this is going to be the conversion angle 10 degrees. And this 270 plus 10 is going to be the great circle 280. So we are going to compare this great circle at initial departure to this great circle at the arrival. So let's see, here we know that this angle, this whole angle is 270, right? This is the 270 angle. But we need to know the highlighted yellow angle which is the great circle at arrival. So this angle is 10 degrees. If this angle is 10 degrees, then 270 minus 10 is going to be 260. So the great circle here at arrival is going to be 260. So if the aircraft is flying in the north hemisphere and in the western direction, then the great circle decreases from the departure to the arrival. Now let's see the example of the southern hemisphere. So if in the south hemisphere and we are flying easterly track, right? So this is easterly track. So the Rhumb line is 090. We know that the conversion angle is going to be 10 degrees, right? So this is the angle 090 and this is the conversion angle 10 degrees. So this great circle is going to be 100. Right, because in the south hemisphere, the great circle is towards its pole, which is below the Rhumb line. Now, at the arrival, we know that this angle is 90 degree. So this is the 90-degree angle, right? But we need to know the highlighted angle here, which is this angle, great circle at the arrival. So for that, we know that this angle is going to be the conversion angle, which is 10. So this whole angle is going to be 080 degrees. So the great circle is going to decrease. So if you are flying in the south hemisphere in the easterly track, the great circle decreases. Now let's see an example of the flying in the westerly track in the south hemisphere. So this is the Rhumb line 270, right? And we know that this conversion angle is 10 degrees, right? So this is the 270 whole. In from that we minus the 10 degrees. So we will get the 260 angle of the great circle at initial departure. And we need to find out the great circle at arrival. So we know that this angle is 270, right? This angle is 270 and this angle, the angle between the great circle and the Rhumb line is 10 degrees, right? Conversion angle by definition is angle between Rhumb line and great circle. So this 270 plus 10 degrees is going to be 280 degrees. So the great circle is going to increase when an aircraft is flying from in the easterly track in the south hemisphere. After that, we'll just revise all the formulas that we are going to use in the numericals, right? So let's revise the formulas, which is the first that we saw was convergency is equals to d long into sine mean latitude. The second formula is conversion angle, which is CA, is convergency in by 2. The third formula we saw was again about the convergency, which is convergency is equals to great circle at arrival minus the great circle at departure. Okay, so this was three formulas. After that, we have one more statement that we need to keep in mind while solving the numericals. Okay, so the statement is if in the question there are two great circles given. Okay, so if the difference between great circle is 180, then both the points are at equator. Second situation is if difference between great circles is more than 180, then points are in the north hemisphere. And third situation is if difference between the great circles is less than 180, then the points are in south hemisphere. Here in the question, great circles will be given for two different points and you need to know that in which hemisphere or at equator the points are. Now let's see some examples of the question. So the first question is we have point A and B. The point A is 59 degrees north and 010 degrees west and B is 065 degrees north and 010 degrees east. The great circle at A is given, which is 050, and we have to find out the Rhumb line at A, great circle and Rhumb line at B, the convergency and the conversion angle. So we'll start by drawing a diagram of the points. So let's say that this is the longitude 1 and this is the longitude 2 and we have a 2 points, right? So this is 10 degrees west and this is 10 degrees east. The latitudes are 59 north, which is this, and 65 north, which is this. So this is point B and this is point A. Now to draw Rhumb line is the direct from one point to another point in a constant direction. And the great circle is going to be the curve convex to the pole and the shortest distance, right? So we are given this great circle as 050. Now what we can do is we can use our first formula of the convergency, which was d long into sine mean latitude. So d long here is 20 and the sine of 59 plus 65 by 2, right? So this is going to be 20 into sine of So the answer is going to be 17.6. So we have the convergency 17.6. Let's write it here 17.6. Now the conversion angle is going to be 17.6 by 2, right? So it is 8.8. So the conversion angle is 8.8. So we have the convergency and the conversion angle. Now we are going to find out the rhumb line and the great circle at B and the rhumb line at A. So we know that this conversion angle is 8.8. So if the angle from here to here is 50 and this angle is 8.8, the total yellow angle is going to be 58.8. So the rhumb line at A is 58.8. How? So the rhumb line at A is 50 plus 8.8, which is 58.8. Now the rhumb line at B we can find out how. So the rhumb line at A is 180 degree to the rhumb line at B. So 58.8 plus 180 degrees is 238.8. So the rhumb line at B this is 238.8. Okay, so let's write here 238.8. Now we have to find out this great circle at B, right? So the great circle, here we know that the conversion angle is 8.8 and his angle is 238.8. So this great circle at B is going to be 238.8 plus the conversion angle of 8.8 degrees, which is 247 two sorry 247.6. So we have all the answers that are needed to complete the question. Okay. So in the next question, the point A is at 075 degrees north and 010 degrees east, and point B is 060 degrees north and 075 degrees west. We have to find out the great circle and great circle from A to B, great circle from B to A, rhumb line from B to A, and convergency and conversion angle, and we are given the rhumb line from A to B. So let's draw the diagram. We have two longitudes here and here, and the latitude points, these two longitudes are 10 degrees east and 75 degrees west. The latitude points are 075 degrees north and 060 degrees north. So this is the point B and this is the point A. To draw the rhumb line, we are going to have a straight line from A to B, which is the constant direction, and this is our great circle convex to the pole. So we are given the rhumb line from A to B. So this is given, which is 2, 4, 5. Now let's find out from the first formula the convergency, which is d long into sine mean let, right? So here the d long is 85 and the sine, the mean latitude is going to be 75 plus 60 by 2, which is 85 into sine of 67.5, which is going to be 78.5. So this is our convergency. Now the conversion angle is 78.5 by 2, which is going to be 39.2. So we have found out two things, which is the convergency, which is 78.5. The conversion angle is 39.2. Now we know that this angle, the yellow highlighted angle, is 39.2 and this angle is 245, right? So let's find out the great circle from A to B. So the great circle from A to B is going to be 245 plus 39.2. So that is 284.2. So this angle is 284.2. Let's write here 284.2. Now the next we need to find is the great circle from B to A and the rhumb line from B to A. So let's see the rhumb line from B to A. Rhumb line from B to A. The rhumb line from B to A is going to be 180 degrees opposite to the rhumb line from A to B. So 245 minus 180 is equals to the rhumb line from B to A, which is 65 degrees. So this rhumb line is 65 degrees. We know that this angle is 39.2 and the whole angle, this whole angle is 65, right? So the great circle from P to A is 65 minus 39.2, which is going to be 25.8. So this great circle is 25.8. So we have found out that this is 25.8 and the rhumb line from B to A is 65 degrees. These are all degrees. So we have found out the great circle from A to B is 284.2. The great circle from B to A is 25.8. The rhumb line from B to A is 65. Convergence is 78.5 and the conversion angle is 39.2. So in the next question, we are given that the rhumb line bearing of x from y is 240 degrees in south hemisphere and the conversion angle is 8 degrees. And we have to find out the great circle bearing of y from x. So let's draw whatever information we are given. So the direction we are given from y to x is 240. So this is going to be your direction 240, right? This is the direction of 240. This is from y to x. So if we can draw the latitudes and longitude, it will be like this. This is your longitude 1, longitude 2, and the latitudes will be here. So this is the direction of 240, the rhumb line from y to x, and the conversion angle is given as 8 degrees. If this is south hemisphere, then the great circle is going to be convex to the pole, right? So we know that this angle is the highlighted angle is 8 degrees, right? So this is 8 degrees. So if we want to find out the great circle at y, so this angle, we can say that it is the whole angle of 240 minus the conversion angle of 8. So 240 minus 8, which is 232. right? So we have found out the great circle from y to x. Next, we need to find the rhumb line from x to y. So the rhumb line from x to y is 180-degree opposite of the 240. So 240 minus 180, which is going to be 060. So this rhumb line is 060. Now we know that this angle, the highlighted yellow angle, is 8 degrees and this angle is 60 degrees, right? So the whole angle is going to be the great circle from x to y is 60 degrees plus the conversion angle of 8 degrees, which is 068 degrees. So this is the answer, the final answer, which is the great circle bearing of y from x is 068 degrees. So in the next question, we are given that the great circle bearing of y from x is 048 and the rhumb line bearing of y from x is 039, and we have to find out the conversion angle, the hemisphere of the both the points, and the great circle bearing of x from y. So the conversion angle we saw, the conversion angle is angle between the rhumb line at the great circle. So it is the difference between the great circle angle and the rhumb line angle. So it is going to be 048 minus 039, which is 9 degrees. So we found our first answer, which is the conversion angle is 09 degrees. Now we have to find out in which hemisphere the both the points are situated. So if we see that the great circle is 048 and the rhumb line is 039. So if this is the rhumb line 039, then the great circle has to be below. If the great circle is 048, so 048 is below the 039 line, right? So this is going to be the south hemisphere because the great circle is towards the south. So this is the great circle of 048 degrees and this is the rhumb line of 039 degrees. So we found out the second answer, which is the south hemisphere. Now we know if we draw two longitudes here and two latitudes points are here. We know that the conversion angle is 9 degrees. So here also the conversion angle is 9 degrees. And this is x and this is y. So the rhumb line of x from y is 039 plus 180. So it is going to be 219. So this angle is 219. So this whole angle is 219 and the highlighted angle here is 9 degrees. So for this angle we have to minus the 219 minus 9. So the great circle of x from y is 219 minus 9, which is 210, which answers our third question, which is the great circle bearing of x from y, which is 210 degrees. Now let's see our last question, which is we have 2 points A and B and both are on the parallel of 30 degrees south. We are given the longitude of the A is 12 degrees east and the great circle bearing of A from B is 260 degrees, and we have to find out the longitude of B. So we are given this information, and this information. So let's draw a diagram from this information, right? So if we say that this is a 30 degrees south parallel of latitude and we have one longitude which is 12 degrees east. Because the direction of A from B is in the westerly, it is a westerly direction of 260 degrees. So we know that the point A is west of the point B. So let's say this is the longitude of the B. So we have to find out this longitude, right? The Rhumb line is from B to A, and this is the great circle from B to A. So the great circle is given as 260 degrees, and we know that this Rhumb line is 270 degrees because it is going towards the west and it is in the parallel of latitude. So this angle, the highlighted angle, is going to be 270 minus 260, which is 10. So we have found out that the conversion angle is 10. So the convergency is going to be 10 into 2, which is 20 degrees. Now, as per the formula, we know that the convergency is equals to d long into sine of latitude, right? So we have to find out the d long. So d long is equal to sine lat, I'm sorry, d long is equals to convergency by sine of latitude, which is 30. So convergency is 20 and sine 30. So convergency, our d long is going to be 40 degrees. Now if we go from 12 degrees east to 40 degrees towards the east, we are going to get 12 plus 40, which is 52 degrees east. So the longitude of B is 52 degrees east. So the point B is at 30 degrees south and 52 degrees east. So this is our answer.